The Arctic is warming at about twice the rate than the lower latitudes where most people live. And that is fundamentally because of the reflectivity of the Arctic is decreasing.
Professor of glaciology at the Geological Survey of Denmark and Greenland, who Rolling Stone magazine called the ice maverick, Jason Box. Jason, how are you, sir?
Well, the process of discovery produces some satisfaction, and I think all scientists, that's what drives them. But we also realize in the process that the story that's unfolding is also one about a climate change crisis that we want to put some hard numbers on. What's driving the desire to understand the climate crisis is driven by concern about us and the future of humanity. We're telling part of a story at a very large scale about an environmental crisis that is due to externalities of our economic system, which makes life really good for a lot of people, but it's those externalities that we're learning about. That climate change is just another symptom of our economic system that externalizes its impact. We need to redefine our economic system in a way that is actually sustainable. I'm getting this question more often now, how do you sleep at night, or are you getting depressed or angry at society and civilization? And I would have to admit that yes, I'm beginning to feel angry about this. I feel guilty, I feel complicit. Climate change as an issue it's really about justice. It's a story of injustice. Injustice in nature, injustice to people that didn't create the problem or feeling its impacts strongest. So it should be an intensely emotional issue, and I think scientists can block most of that, because their job is just to go after facts and numbers, and they can get lost in that process. That the process itself produces satisfaction for a lot of people, and they want to end it there. They don't, myself included, you don't want to take on the real significance of what we learn. What we realize is, our economic system is fundamentally flawed. Probably the most clear signal comes from the ice, the story that ice tells us, because ice is such a sensitive indicator of change. Some call it nature's thermometer. If the ice goes away, we know that the climate has warmed. It can be that simple. So those of us that study the cryosphere, the frozen part of our planet, we have the benefit of our laboratory, our natural laboratory, telling a lot of the story for us. We really just need to go to the Arctic and observe, and a lot of the story is told just by the changing landscape. Albedo's 0.38, it's pretty dark, and our instruments level, we're ready to go at this site. Last summer we spent 2 months camping at this one location, and during that time we saw the surface going from fresh snow to a bare ice surface that then got darker. We think about snow as pure and bright, and in reality there's small particles that it's sometimes not easy to see with your eyes that has a darkening effect on snow. And what our science is telling us is that if there's a big fire season, there is more black carbon on the surface of the snow, and that black carbon actually concentrates up on the surface as the melting snow goes down. So the surface of the snow gets darker through the melt season. When a leaf from a tree falls on a frozen lake, you can see that it actually sinks down into the ice because it's darker than the ice and it's absorbing sunlight. And we see that on the Greenland ice sheet with these dark material. It becomes concentrated in holes, and they're full of water because it's like these are become like solar collectors. When you look at that material at the bottom of these so-called cryoconite holes, there's an ecosystem. It's an organic material. So it's a little more complicated than what I thought when we started out 3 years ago.
Whew. Pretty wild out there. So we're having a weather day. Gives us a bit of time to explore different opportunities.
Greenland is a vast natural laboratory that we kept going back to year after year because we had to maintain measurements in a long-term program. I could see bigger changes happening, and the question of wildfire and what effect that has on darkening Greenland, that just hit me in the face in 2012 when my home state of Colorado was on fire, and I had not yet made that connection between fire and the darkening effects on ice. We had been studying the reflectivity of Greenland and finding that warm summers were darker just because there's more liquid water on the surface. But then when we brought the fire part of the story in, that added this other dimension. All of these things come together to have a strong multiplying effect that on Greenland, for example, in the last 15 years, without this effect, the increase in melting would only be half as large. So it has this kind of doubling effect because you have multiple different darkening factors that are further enhancing melt, because the darker it gets, the more it melts, the darker it gets. Today, the climate models used to project future climate, they still don't have in darkening from wildfire. And the climate models also don't have ice darkening from biological factors. It's not that no one had thought about it before, but what was missing was hard numbers. How much reflectivity decline do you get from wildfire black carbon? How much reflectivity decline from biological factors? Those numbers didn't exist. So what we've been doing each year for now 3 years is taking surface samples in snow, like drilling down snow cores, measuring black carbon concentrations. So we're also measuring reflectivity on the ground to see if what we're measuring from satellite when we map reflectivity over all of Greenland is how accurate is that. We're also flying drones that give us a much more detailed picture of how much of the darkness is due to snow, how water, bare ice, just those three surfaces. We are looking at wildfire occurrence on the whole northern hemisphere scale, mapping that. We're hitting the problem with a lot of different sources of data, and we now have calculations that can be put into climate projections, and what we expect is another kind of doubling in the next century of melting just due to these feedbacks of darkening.
So the air temperature is 0.89 Celsius, so it's enough heat in the air to melt, and then there's all the sunlight, of course, that's melting the surface with this dark material, absorbing more sunlight.